Thank you all for being here. Welcome everybody to FabFems Friday. This one is all about electrical and computer engineering. If you are new here, every single week we do a profile on a different type of engineering that is offered here at the University of Texas at Austin. We always have amazing partners with UTWEP, working professionals in engineering fields, sometimes some current students. So, get your questions ready. We have awesome people to hear from, and you'll get to learn a lot about ECE, or you might hear it referred to as double E as well. All the same thing, roughly. Anyway, so today we are talking about electrical and computer engineering. We have some amazing alumni here today. Today we don't have any current electrical and computer engineering students at current students from the University of Texas. So if you have questions that are specific to a current student, then you're going to default to any of the resources that I'm about to send in the chat. Here we go. So the first one I sent is our UTWEP YouTube channel. We have so many playlists and videos there from current students, from alumni, from engineering friends all across the country, kind of answering commonly asked questions and sharing resources and stuff like that. That is an excellent place to start getting your questions answered, especially from a student perspective. The second link that I sent is the database for FabFems National STEM Role Models. So basically you can go on there, search things based on identity, geographic region, what field they're working in, anything like that, and find a role model that you want to connect with. Again, an excellent resource. And then finally, that third link is to our Camp Questions Google Sheet. That, if you keep checking back, we're basically updating it with questions that we're getting from our summer camp people, questions from these webinars, and then current students will go in and answer those questions for you. That's a really helpful resource because it's being updated really quite regularly. And so I don't know, kind of a nice conversational way to get your questions answered. So excellent resources there, but today we will focus on our panelists. We have, let's see. Sorry, we have two people from our virtual summer camp corporate partners from Texas Instruments and Samsung Austin Semiconductor. So shout out to them. Thank you for supporting our summer camps. But with that, I will pass it over to our panelists to get themselves introduced. Just tell us your name, pronouns if you would like to share, where you're working, maybe like how you got into that position, any kind of basic info before we jump into the actual questions. Let's start with Gauri.
Oh, okay. Hello. 1 second. I need to see myself so I know I'm actually visible on the camera. Hi, everyone. I'm Gauri. And before I start, Rain, Sarah, Thanks a lot for organizing this webinars. I think it's a fantastic idea. And I'm very happy to be one of the participants on this panel today. Really appreciate the opportunity. So yes, my name is Gauri Karve. I'm not supposed to call myself Dr. Karve. Apparently, PhDs can't do that. You have to say Karve PhD. So I come from a small town close to Bombay in India, and I joined UT Austin in 1998. Yes, I'm very old, and I came in with a master's in physics, and I joined for a PhD in physics, and then I switched to electrical engineering. So I finished my master's and PhD in electrical engineering from UT Austin, and my topic was photodetectors for quantum communication. So that's very exciting, a lot of fun. After that, so I'm an industry professional right now for about 15 years or so, and have worked at Freescale in Austin before, as well as IBM Research for about 9 years in New York. And 2 years ago, I changed the jobs and I moved to Belgium. And there is a research institute called IMEC, IMEC. So right now, I'm a researcher at IMEC.
Well, Dr. Gauri, you really, I don't know. I mean, why not? I cannot say anything now.
See, I can't say Dr. Gauri. My mom tells me, you're not a real doctor, okay? Just remember.
No, I always respect people spend that many years in the research and in the program. Really, I always have I chicken out for many years. I'm not going to get into that. So you are the inspiration. Okay, well, this is Yim Meyer. I born and raised in Hong Kong, and always impressed with the culture in US. So I come here for the computer science degree. UT was killing. And I'm sure all of you know what's going on. I mean, you just sleep, eat, just at the campus. But I do appreciate afterward all those knowledge and the professor I get. So after UT, I get an internship with Dell for almost 10 years. And I stopped several years to be a full-time mom. And I come back, work for AMD and work for GE Aviation. And then right now I'm with Samsung. So to me, it could be intimidating. Most of colleagues around you is men, but just hang on there. It's not that bad. And usually they kind of, because you usually is the only girls in the team, usually they kind of quite good about that sometimes. So that's me. Who is next?
Awesome. Thank you, Yim. Caitlin, would you like to introduce yourself and like your background?
Sure. Hey guys. So my name's Caitlin Mazzarella. I'm originally from New York, but living in Dallas now. I studied Bachelor of Science for Electrical and Computer Engineering. I'm currently at Texas Instruments. Sorry, there's a neighbor dog barking. I hope you can't hear that. So I'm currently at Texas Instruments. I've been at TI for about 6-7 years now. Came in through an internship and got a full-time role after I did my internship. And so I'm in a technical sales and marketing, business development type of role. So very different than what I would have expected, but it's a really fun way to use my technical knowledge and also to connect with customers and new applications. So I'm really happy about that.
Wonderful. Thank you, everybody. So those are our 3 panelists for ECE. We also have 4 current UTWEP employees on the call today. So Maria is a civil engineer, Sarah is architectural, Maya is environmental, and then I'm chemical. So if you have a question kind of about the general structure of engineering at UT, we might be able to answer it, but we'll mostly focus in on electrical and computer engineering. If you have questions throughout this panel, then send them in the Q&A function, upvote them if you want to hear them answered, because that is what we'll be pulling from. And anything that we don't get covered, we'll either add to that Google Sheet I sent earlier, or if you're a summer camp participant, then we'll be adding them to our Padlet as well. So with all of that out of the way, let's jump into our first question that we have. This is for all 3 of our panelists, so anybody can go first. The question I have is, what made you decide to pursue electrical or computer engineering? And can you share a bit about your work in this field? For example, maybe share an example of a project you've done. What problem were you trying to solve? What was your role as an electrical or computer engineer? And how were communication and collaboration involved? That was a huge question. So generally, tell us a bit about why you decided to join this field and maybe a problem that you've worked on in your recent career or before recent. That's fine too. Anybody can start.
Yim or Caitlin, why don't you go first?
Because embarrassing. Well, talking in front of you, well, you know what? It's so embarrassing that I cross out the major I don't want, and they end up to be computer science or physical therapy. That is my story. So girls, you girls go ahead.
Hey, so
Sure,
what?
I can share a little bit.
Okay.
Yeah, so in high school, I always really enjoyed math. Calculus was my favorite class. None of my friends really could relate, but I just really enjoyed it. My sister is an engineer. My father is an engineer, so I think it just runs in the family. And so really got heavily into calculus, discovered computer programming, and then I just thought it was a really fun way to solve problems, and it just made sense to me. I enjoyed my English classes too, but was not my favorite. I just always liked the science and math aspect of things more. And I think engineering is just so fun because it's, some of these problems can be very ambiguous. There's a lot of different ways to solve different challenges. And in my role today, I'm not doing any design engineering, but I'm enabling design engineers to solve their own problems. So I'm trying to think of an example of a problem I've solved recently. So we have a lot of different solutions at TI. And so one really fun thing is aligning our solutions with what customers need. So there's a lot of changing requirements in the market, especially in industrial automation. Industry 4.0 is a grow and new trend. And so we have devices that can support different protocols, higher speeds that help industries and factories become faster, more connected, more intelligent, and emphasize the safety aspect, because there are still people in factories. So we need to make sure that, you know, safety is a priority.
I will put Kaylin to be my speaker. She speaks perfectly for how to choose the major. Very good.
So my story is a little different. So in school, I don't think I really enjoyed math that much. I never thought I was good at it, honestly. But then my sister decided to choose physics for her degree. Like, ooh, she's doing it. Cool. That looks cool. So I decided to go to physics. Really, that was the reason. And then what happened is, so I got my master's in physics, and then realized that I'm more interested in application-oriented research. You know, something I can see and feel, which is the reason why I switched from physics to electrical engineering. And one of the examples, and that's this. So, does anybody have iPhone? Any of you, or know somebody who has iPhone?
Yeah.
Okay. So, starting iPhone 5, which was launched in 2013, there is a device in that iPhone that I have worked on 12 years ago at IBM.
Yeah.
So there you go, an application.
Yeah,
and that is the kind of thing that makes me kind of smile. That every time I look at an AMD laptop or look at an iPhone, like, hey, you know what? I did something that enabled it. So and again, of course, this was not a single person effort, right? It never is. It's always a team, always a huge team. But just being part of a team that enables a solution and that's actually changing people's lives. So that is the job satisfaction part that I find being an engineer. So in the last couple of years, I've changed the field a little bit. And right now I'm working on infrared cameras. So, you know, an application could be, let's say, if you have the driverless cars, right? And if the car is driving at nighttime or through fog, how are you going to see? How is that computer going to see what's in front of it? So you need the infrared cameras for that. So right now I have like a fantastic team that I work with, and you know, just get them to be cheaper, more reliable, more faster. You know, like the basically the next generation for the IR cameras. So that's my current work. But yeah, I think being able to connect with day-to-day applications and life, that's what appealed to me. You know, when I decided engineering over physics in this case, and I chose physics because my sister chose physics. So yeah.
Really appealing, the infrared project. Really interesting.
Yeah, it is. Yeah, and that's the thing. It doesn't matter what background you really come from, but with an engineering degree, and not necessarily electrical, but I think what you are actually learning is how to solve problems, right? That's the key here. So it doesn't matter which field it is. You can pick and choose and move later. And I mean, look at Caitlin. She's solving problems in business development. And I work with some of the folks in that department, and it's amazing because you know the technical things, you know the business side of things, you are kind of putting them together, right? And so there are so many unique opportunities that a EE degree is going to offer. Yeah, so go EE.
Yeah, and a CS also.
Oh, CS too, of course.
Awesome. Thank you, Gauri. I completely agree with that. Something you'll hear a lot if you come to UT, and especially in WEP, is that engineering really is a problem-solving degree. So whichever major you end up choosing, I know I was definitely torn when I was like picking which engineering major. You're really getting a valuable skill set no matter which one you pick, and you'll be able to branch out into a lot of different fields.
And in the industry, you'll see there are so many people you work with, and each one is from their own background. And there could be a petroleum engineer, there could be a computer, or biochemical, but they each bring their unique perspective to the table, right? And that's what makes a project successful. So I think, yeah, it's about how do you systematic problem solving, and yeah, I think UT really prepares you for that.
Definitely. Yim, would you like to share a little bit about what you do at Austin Samsung Semiconductor?
Oh, well, I'm more in the administrating the fabrication tool at the background. So that is a lot of analytic, and we are talking about terabytes of data. So my tool set is a lot to do is analyze, look in the trend, how well the manufacturing is doing. So small little thing that sometimes can get us excited. Funding as little as just how to identify where the problem coming from. I mean, you are reverse engineer to going back to the plumbing. Sometimes people ask me, what do? I say, I'm just doing a plumbing business, because you are just trying to figure out which plumbing is broken and where the data coming from. And so our team is called data science. So we do a lot of data, but we also, in the production side, I do a lot of maintaining, make sure the fabrication tool is running smoothly, humming.
Great. Thank you all very much for sharing, kind of giving some context about like what you're doing day to day, what kind of work an ECE can do with their degree. The next question I have, and this one is a pretty common one I get as a student employee. A lot of people ask me this. What is the difference between electrical and computer engineering or computer science? Or at UT, we also have something called computational engineering, which is even a slightly different aspect. So if any of you can speak to that, kind of the difference between an ECE or a double E and a computer science major.
Yeah, sure. I have some thoughts that I can share with you on that. So basically, I don't know what computational engineering is actually, because I don't think it was there when I was.
We like math.
There you go. Okay, the math people. All right. So there are three fields, the three disciplines, right? Electrical engineering, then there is computer engineering, then there is computer science. So, okay, what is the difference between all three? So take the example of the iPhone again. You have your iPhone in your hand, right? What does it have inside? It has probably like a microprocessor, it has some memory, some antennas, etc. The person who designed the specifications and actually laid out what should it look like, that person is a computer engineer. Okay, then somebody had to physically make it, fabricate the system. That is electrical engineer. Okay, and the iPhone is running with an operating system in the background. There are apps, there are databases. That is computer science. So that's at least my very loose definition of how you can separate these three. But truth be told, right, that in the industry, these fields and disciplines, they overlap quite a bit. So it's not that because you are an electrical engineer, you will not do any software work. That's not true. It's just, I'm generalizing the definition of the discipline right now, but that's at least how I think of it. Just the example of the iPhone, but that would be the difference, that with computer science, it is mostly troubleshooting issues at the software level, handling a lot of data. Yim is a very good example, right? And those guys like mathematics.
Thank you. That's the way to go, rock. Math rock.
Whereas with the computer engineering, that person is more of an interface between the software aspect and the hardware aspect. And for electrical engineer, it's mostly about, I have like a box of Legos in front of me, and you're asking me to build a giraffe with it. Okay, fine. How can I build a giraffe with this box of Legos? So that's at least how I have compartmentalized these disciplines.
What do you think, Caitlin?
Yeah, what do you think,
That's
Caitlin?
a great summary. I think that's a better summary than I could have given. I like the way you think through to make it a relatable example. And so when I actually started my major, I started with computer science. I had taken some programming classes in high school that I really enjoyed. And I got about a year and a half into it and said, okay, I don't know if I like being on the computer this much, just programming all day, usually by myself. And so I actually made the switch from computer science to electrical engineering just because I really recognized after just one intro to electrical class that I just enjoyed the hands-on aspect of it. I liked being side by side with my classmates, all working on a common problem with a physical board in hand and getting to see the results. So that was, you know, to me, a big switch of just getting to be able to be more hands-on.
Oh, okay. I need to say something about CS, computer science. Come on, girls. When you make a line of code change, just little thing, and suddenly the program work, isn't it a lot of satisfaction?
I'm sure.
Yeah, and how many? For me, it didn't happen that easily. It was always trying to find the one little line that was broken. It was enjoyable. It was very satisfactory. Yeah.
But I agree with you, Caitlin. At least personally, it was very difficult for me to go from like a small program to a big one. I, started losing patience basically with myself.
Yeah.
But yes, without the computer science, of course, we won't have the enabling technology. It's a backbone for pretty much everything we do right now.
I think we all work together. Really, pick a major. I'm sorry, my phone. I think is sometimes when I look back, although I say that I crossed out the major to going into computer science, and oh, by the way, I almost go to physical therapist, but only because UT, the medical school is Galveston, and I know no one in Galveston, so I stuck in Austin. That's how I end up here. But I do notice that when you start taking classes, because classes are all difficult. I mean, you just you study, right? But you will persist, continue to that class. And I think it does, later on, I realized that it does because it does interest you. Because hard, everything is hard. English is not my native language. So people read 3 times, I read 5 times in order to understand what's going on, to move on. But somehow I would persist in trying to do that. And so I think it does tell you that really is your major. And also the people around you. I mean, you will talk to your classmate and then you like to hang out with them. And compared to, probably I don't survive in the art school. My daughter is in art school. So I went over, go to the school. I said, so it does give you the feel that you may, at that time, I may not know that is really the major I like. But later on, when I think back, it does. It is something that, because you try to continue, you work on it, you hang out there. And the people you like to hang around, and you can talk to them, although they are funny, but you still like to hang around with them. It does. It really, that's your major. But usually backtrack, going back and have a look back. Yeah, I make the right choice. So girls, stick there.
And I think for all the interns who still are thinking about what major is right for them between all 3, right? Look through the website, the link I think that Jane you have sent out, where you can just search through and find out a person with a degree in this particular major, where have they landed, and see if you can imagine yourself in that particular career, for example. Right, that's one way to kind of check. Okay, is this a kind of thing I see myself doing, say 5 years from now or 10 years from now? And if the answer is no, then you need to change or rethink the strategy.
Absolutely. All super excellent advice. Thank you all so much for sharing. I'm going to drop one more thing in the chat for y'all to look at. That is like a UT document that explains the difference between computer science, electrical and computer engineering, and computational engineering, which is a newer degree at UT. So if you're interested in that, look at the document. So with that, that's the only planned questions I have. So I'm going to turn it over to our other 3 WEP employees, and they'll start, just unmute and read us a question from the Q&A that people have been voting on.
We have a few questions that are asking about kind of the difference between like software and hardware. Can you talk about if you work with that and if you've had any experience with both and like which one you preferred and how you knew which one you liked?
Yeah. Caitlin, do you want to take the question or?
Well, so software, hardware, you girls know. But at the end of the story, usually you will know both in order really, yes. But so when I start my career, oh God, I hate BIOS because BIOS using all machine code, but you have to know it. Well, I don't have to be so good at it, but just kind of need to know, understand a little bit what's going on. So when I discuss with the BIOS team, I know what they're talking about, what's the difficulty and what I need to do to support them. So, but you go back to your major though. So if you can hang around, for example, Kaylin will start with computer science, but she will move into electrical engineering. So that can tell you a little bit what you like, don't like. And I remember I being computer science, I need to take some EE class. I die there. I mean, and so I mean I will take it, but that is not something that I will spend more time I need. I will not continue to take on it. I get my class, I'm done. But for computer science, it intrigued me. I will spend more time in the computer, trying to change in the code, make it more slick. So that kind of give you more satisfaction when I take the class.
Yeah.
So it will be really applicable to what the major you think. I mean, it is hardware or software. CS, sure. CS is more software based, but you still need to know quite a bit about the hardware.
Yeah, and yeah, just to add to that, Yim is absolutely right. I mean, I will classify myself, I think, as hardware engineer, but still I need to be able to do software as well, because sometimes there is data that's coming out that you need to figure out how to process in a more efficient way, right? Or just be able to talk to the colleagues who are helping you with it. So you still need to know the terminology. And again, I need to be a little careful because hardware is not always that you are handling or doing things by yourself, correct? So it depends. If you are in academic setting or in a lab, for example, of course, everything will be hands-on and you will be doing it. But in the setting that I currently am, which is the industrial setting, the pace is extremely fast, obviously. And then they don't have the patience for one person to execute every single step, in which case you have to rely on other people to actually do the execution of the experiment that you have in mind. So even now I'm a hardware engineer, but my main thing is basically designing experiments and different ways of doing it. But when it comes to actual execution, then I rely on the fabrication individuals, right? Or people in the lab to actually do it for me. So I would say that so there is a distinction, software versus hardware. However, I think you will be able to pick what you want to tend towards. So for example, early on, I had a choice. If I wanted, I could have stayed more with the lab work and stayed more hands-on. But for me, more fun is being able to look at like tons of different projects and coming up with tons of different ideas on paper and then get executed somewhere else. So a lot of it also depends on your own inclination, on if you would like to work in big teams, you like to work by yourself, you're more hands-on in the lab, or you also enjoy coding, in which case you should be able to do both, which is what I can do. That, just do a bit of a coding if I need to, at the same time have one foot in the lab, so to speak. But yeah, the difference is computer science, like Kim said, is more on the software side. Electrical engineering is more on the hardware side. That's how I would separate them.
Yeah, and I would just add to that. I think, as you're going through your courses, your courses are going to be difficult. They're going to be challenging, but thinking through the different, the coursework that speaks to you, that, really stands out to you, that you really get excited about. And, it's like I said, it's going to be challenging. when you figure out the problem and when you get to that solution, you know, where are you getting more excitement from? Because for me, it was very personal. I would get past it from the programming side of things, but in the lab, when I would get something, I got personally more excited about it. But in a lot of roles, you're going to be dealing with both. So right now, as a product marketing engineer, I'm dealing with hardware and I'm also dealing with software. And so that's something that's pretty new in a role that I started about 3 months ago. And so that's been getting back to my programming roots, understanding, you know, what the software offers, you know, how the stacks look, how our engineers are going to be using it. And so it's been a good, you know, exciting experience getting back to software for me, because I do enjoy it. And so it's nice to be able to do a little bit of both.
Yeah.
Awesome. Thank you all so much for the insight. We have a question for Caitlin regarding business. So can you talk about how you gained the relevant business experience in addition to your technical engineering experience that allowed you to work on business development in your industry?
Sure. Yeah, so I have no formal business training. However, so at Texas Instruments, the training rotation program that I started was specified for technical sales and product marketing. And so when you start the program, they spend a full year developing you. They send you to a marketing organization to learn in the role from team members. You get assigned a mentor. You get assigned a buddy who's usually someone with a lower experience level who you maybe feel more comfortable asking those seemingly stupid questions, but no question is ever a stupid question. And so, yeah, really, really on the job training. TI also offered negotiation trainings, different business development, just to help us, you know, recognizing that they're hiring engineers to do business roles, you know, recognizing that they had to invest a little bit more there. And so that was really how I've learned.
Helen, I think that is a really difficult role. I mean, I bravo, you take on that.
Yeah. And I think having this engineering background,
it.
when you do business development, I think it's fantastic.
Yes.
Because it's much easier to talk to both sides of the coin, right? You can talk to the engineers and at the same time you can negotiate. I think that's really fantastic. Yeah. It's very nice to see that, Caitlin.
Yeah, it's a great role. I really love it. I was worried when I was going into a business role. I did it as an internship first because I saw many engineers that were struggling and went to a business major. And not that there's anything wrong with that, but I didn't want to feel like I was leaving my engineering roots because I worked really hard to get to my degree. But in the business engineering role, in order to be really successful and connect with customers, you have to understand the engineering side of it. Mm-hmm. And understanding it and relating it to customer problems is really exciting. I feel like a consultant sometimes, you know, able to help engineers that have a ton of experience, but we at TI for the product marketing engineering role will be product market experts on one specific type of product. And so we'll dive very deep on that and meet a customer who's maybe doing an iPhone and doesn't, you know, is trying to choose the next processor or a microcontroller. Mm-hmm. And so we'll be the value add with the product level expertise on the actual device, and then working with, you know, engineers at Apple on the iPhone on, you know, how to select the device and what value they need.
Nice. Basically, you can speak both languages.
Yeah,
right?
In high demand.
And I think it's a very good idea, Caitlin, what you have done, that starting with an internship, right? So to get a feel for, is this something that you like before you jump head first into a business degree, for example. I think that was very smart. Yeah. And I think it's a good idea for everybody just to try it out on a 3-month, 6-month basis. See how you like it.
It's a role that not a lot of people know about. So when we do career fairs at UT and talk about it, a lot of people don't seem to know about it because I don't know that it's, you know, a common career path, but it definitely is something that I was surprisingly excited about doing the internship, enough so that I came back full time.
Yeah, nice.
So a couple of people are asking about the coursework associated with ECE. So I was wondering if maybe you could talk about some of the various paths you could go down with that major, whether it be research, artificial intelligence, nanotechnology, cybersecurity, and so on.
Okay, so in EE, I'm going to carbon date myself because I took classes in 2000. I graduated in 2005. Okay, so my information is really old. So we had to take 15 credits total, which was quite a bit actually. And so in my case, my PhD actually was completely in the lab. So, and it was optics based, right? So I had some core classes in the optics and nanofabrication, for example, but I also took classes in the design itself, which is more towards computer engineering. And that helps a lot because it gives you, again, it's like learning to speak somebody else's language. So at a later point, you are able to appreciate what they go through and what they are talking about. And of course, the minor classes were in physics department for me, but they don't have to be. So I think most of the classes I took, it helped me give a pretty broad overview. I took a networking class also. Why not? But it was more about just being able to identify what are the different things people do in general with any kind of engineering, and get a feel for it. So that was the main goal, at least for me. And the core classes, of course, those are the ones that you have to ace them, right? Because that's what you will put on your resume at the end of the day. But yeah, so I think I'm sorry, but I think things probably have changed quite a bit, especially with AI and computational engineering. But I don't have the latest information on that.
Okay, thank you for sharing. I also dropped a link to the website for like the current UT ECE degree plan. You can see on there they have some degree requirements, and it looks like they also have kind of like technical tracks that you can pick. So probably around like end of your freshman or sophomore year, you would probably pick something you want to specialize on a bit more. With that, we're getting close to the end of our webinar. So I'm going to ask one final question and give all of our panelists a chance for like final words of wisdom and anything else they want to share. So with that, my final question for everybody is, what is one thing that has been fantastic about your experience pursuing your engineering career? What have you loved about it?
Kaylin is in business, so she starts.
Yeah, I can talk a little bit about it. I'd say, whether it was from my time in university or my time at TI since I've been working, really the most exciting thing is overcoming challenges that I, in the moment, sometimes didn't think I could get past. There were some classes that were real struggles for me. There have been business challenges that have been real struggles for me. My current role that I mentioned I've been in for a few months, the technology is very different and much heavier on the software side than anything I've ever dealt with. And that's been very challenging for me to ramp up on, especially we're currently working remotely, returning to office soon, but it's tough. And not being afraid of a challenge and not being afraid to push through and ask for help, that's really been the greatest experience, is the connections that I've made and the help and guidance that I've received, both from coworkers, from mentors. When I was at university still and looking to apply to TI, there was another UT alum that worked at TI, and she was a really great mentor for me and really just helped encourage me that, I could get the job, that I could be successful. So that's been a really good experience.
Okay, so fine, I'll go next. So I think the best part is working with people. That hands down, that wins for me. And you get to meet with so many people from different backgrounds, different inputs, different cultures, different nationalities, men, women, and it's just fascinating to me because every person has such a unique point of view. So me personally, that is one of my most enjoyable aspects, and just coming up with solutions and challenging each other. I mean, it's kind of cool to get paid to have fun, and being given problems to solve. And like, all right, what can we do here? Just be innovative, and sometimes just crazy innovative. So that definitely is one of the interesting things that I personally find. And constant learning, that's another part of it, right? That it never ends with a degree. It never does, because in the industry, no matter what career path you choose, there will always be new things to learn, of course. because there is something about training on the job that everybody has to be ready to do. And I think having a degree from UT really prepares you for it with all the grueling coursework, and it's a pretty high standard to get a degree from UT. And so I think all of us are very well prepared to handle the challenges as they come at, having received a degree from UT. So just keep that at the back of your mind, that the main thing to remember is you're always going to be a student, no matter how old you are, no matter how many degrees you have gotten. Look at me. I joined this company I make 2 years ago, and I have joined completely blank slate. I had no clue what they do. They're like, oh yeah, don't worry, you will learn on the job. Yeah, fine, sure, why not? And if you have to pay me to learn, of course I'll join you. But so keep that attitude, and keep yourself always a student in your mind, and that's going to take you really far, because then there's always fun in a challenge. The challenge is an opportunity, it's a fun, and whether you fail or succeed, it doesn't matter. Have fun along the way, because that's the most important thing in my mind, at least. And I think for summer interns it's too early. But the other thing I realized is that at UT, of course, the biggest concern was, am I getting enough publications? And my God, when is my next exam? And, I'm not done studying for this test. But then after joining industry, I also started my family at the same time. So then the family versus work balance, that is the one thing I've struggled with for 15 years now. I have 2 kids. And I'm looking at you, because I know you took time off from work to take care of the family, right? And I mean, I've been in that situation multiple times. But that's when I realized that, hey, you know what? This is my career. I get to choose what pace I want to set for it. I'm going to decide when I'm going to back off and when I'm going to go headlong. But just being comfortable with, just accept the situation in front of me and do what feels right. Just do what feels right to you, and always be a student. That's for the whole life. And you will have a blast no matter which degree and what job you take. That's at least like my motto. Keep learning, keep learning.
Well, Dr. Gaurav, you well said, and Kaylin also. I mean, you both have really good thought. I mean, excellent thought, I would say. But one of the reasons I come to this panel is I hope to keep the girls stay on in the tech field. Because it is not probably may not be, you feel may not be easy, but it's not that hard either. It's really not that hard. So I highly encourage you girls, keep doing it, and go with the career. And probably you will find it more exciting than you think. Yeah, it is. I hope you girls keep the major and continue to the career.
Yeah, and remember, you're not alone, right? There are so many women, who are in the industry itself, academia, as well as students. And I think pretty much all of us have similar problems, in some form or the other, right? So you're not alone. So make sure that you reach out if there is a problem that you're not able to think through. Ask for help, and find friends, mentors who can guide you through decisions which are sometimes difficult to take. But at the end of the day, this is your life, this is your career. Manage it so that you are happy. That's I mean, the most important thing anyway. So
amazing. Thank you all so much. Couldn't have said it all better myself. Wonderful advice. So take note and let that percolate and everything. So thank you so much to all of our panelists. A special thank you as well to Texas Instruments and Samsung Austin Semiconductor for supporting our virtual summer camps. Hi to all the summer camp participants. Thank you for being here today. I'm going to send a couple more links in the chat before we finish up. So again, I sent our web YouTube channel. Check that out. Our FabFems National STEM Role Model Database. Fantastic place to start connecting with people. Just send them an email and ask them about their career. then our Google Sheet for all of the questions we've been answering through WEP students. And then lastly, if there's a question that you have that wasn't answered today or is not yet answered in the Google Sheet, send it to us at that email and a WEP student will read it and send an email back to you. So really awesome resource there. So that's all we have for you today. I hope you all enjoyed and learned a lot. Thank you all so much for being here, and join us next week to learn about mechanical engineers. Yay!